Alright, so problem number one on the calculator portion of the test, a farmer has 6,000 feet of fence. This is an optimization problem, so it's going to be a lot like the box problem from last unit. She plans to make two equal and adjacent areas separated by a completely straight river. So picture this situation. You gotta be able to visualize what's going on here. We've got a river running through this area, and then we're going to have two equal pens on either side. No fences needed along the river. What are the dimensions of each of the areas that will give the maximum total area? And we should have said that these were rectangles, so that should hopefully say it on yours when you do this problem, because I'm going to change that. These are rectangles. So we have 6,000 feet of fence, so we need to figure out how to refer to these dimensions. So for the time being, let's just call that length, whoa, that was not correct. Let's just call that length x, which would make that x, and that also x, and then let's just call this y and y. Actually, I'm not even going to call those y, y. I'm going to go z and z, and you'll see why I'm doing that in a moment. So we need two things here. First off, we need to find, we're trying to find the maximum area, so we're going to get the area equation. A of x equals, and I'm just going to say A at this point. Maybe you see why I'm just saying A. But area equals, the color changed. Area equals, well, it's going to be base times height, so it's going to be x times z. But we have two of them, so it's going to be 2xz. Now the problem here is area is unknown, x is unknown, and z is also unknown. So now we need to use the fact that we have 6,000 total feet of fencing, and going into that 6,000 feet, I'm going to have 4 x's and 2 z's. So I'm going to solve this for z, so I'm going to get 6,000 minus 4x equals 2z, and I'm actually going to go straight to this. I'm going to divide both sides by 2. You can simplify this again. I'm going to get 3,000 minus 2x, and I'm going to go even farther. I'm going to pull out a positive 2 and get 1,500 minus x, and that's where I'm going to stop, because looking at that, I can easily see that my domain, when I graph this on my calculator, should go from 0 up to 1,500. So that's a big clue to your right there. So let's plug that in over here. The area equation is going to be 2 times x times that value, which is 2 times 1,500 minus x. So I'm going to go 1,500 minus x, and I'm going to combine that 2 with that 2 and get a 4x times 1,500 minus x. And again, because that way I can look at it and determine what my domain should be. So a good tip to graphing this and getting a good window is, as I said, if you can define a good domain like we did with the way we factored it, knowing that 1,500 was going to give us a 0, then we know that we can give ourselves an x range of 0 to 1,500. Now once you've defined your x range of 0 to 1,500, you can just hit zoom and do option, what is it, think 0, which is zoom fit. If you do zoom fit, it'll automatically adjust the y values to the x values that you have chosen. So that's what I did to get this graph, and then I traced second calculate maximum, and I found that maximum value right there. The x value was 750, and the y value was 225. How many zeros are there? 1, 2, 3, 4 zeros. So, dealing with 2,250,000 for y. But remember, that is talking about my area. Y is representing the area. So x is literally that x right there, but y is the area. And that's why I chose to call this side z and not y, because I wouldn't want you to get confused about that. So it says, what are the dimensions of each of the areas that will give a maximum total area? Well, we are going to get the x value, which is 750. It's going to be one of our dimensions, by the z value, and z is plugged in right there, 6,000, or we have it even more simply, z is 2 times 1500 minus x. So 1500 minus 750 is 750. 750 times 2 is 1500. So we got 750 times 1500 for the dimensions of just one of these areas.